Hello, this is the third entry in a series of discussion videos about curve sketching. So for the third exercise problem, you are being asked to sketch a possible graph of the function f given the graph of f prime below. We should also assume that f is continuous everywhere. So this is actually the graph of f prime. Okay, if you want to a possible sketch uh, of f, we should first uh, take note of the take note of the critical numbers and the possible points of inflection of f. So how do we find the critical numbers of f? We find the critical numbers of f by looking at the zeros of f prime and the zeros of f prime and the points where f prime is not defined. However, as we can see from this graph, f prime is defined everywhere. So we should only look for its zeros. And obviously, the zeros of f prime is at negative 2, 0, and 3 minus square root of 2. So I'll mark them for you. So the zeros are in here, here, and here. Okay, so we should also look for the possible points of inflection of f. So the possible points of inflection of f can be found by looking at the zeros of f double prime, or the second derivative of f, or at the points in which f double prime is undefined. So f double prime, so for each point in the graph of f prime of x, f double prime of x is the slope of the tangent line of f prime of x. So if we look at the point negative 1, we have a sharp turn in here. So that means, so a sharp turn means an undefined tangent line at that point. Therefore, at x equals negative 1, f double prime does not exist. So at x equals negative 1, we have a possible point of inflection. As also we can see from the graph of f prime of x, the tangent line at x equals 0 is a horizontal line. So, and we know that the slope of a horizontal line is 0. So f double prime at x equals 0 is 0. Therefore, it's a possible point of inflection. And okay, we also have a sharp turn at x equals 1. So there's a possible point of inflection at x equals 1 as well. Now, we can partition R using these points. So we can construct the table of signs of f like so. Interval f prime, f double prime, and the conclusion. So the first interval should be negative infinity to negative 2, negative 2, negative 2 to negative 1, negative 1, negative 1 to 0, 0, 0 to 1, 1, 1 to 3 minus square root of 2, 3 minus square root of 2, and 3 minus square root of 2 to positive infinity. Okay, it's quite obvious that at the interval negative infinity to negative 2, f prime is negative. Okay. However, the tangent lines at this interval are always facing upwards, or you have a positive slope for these tangent lines. Therefore, f double prime is positive in this interval. Therefore, the conclusion is that you have an increasing f, a decreasing f, which is concave upwards. When at x equals negative 2, f prime is 0, and f double prime is still positive. So you have a relative minimum by the second derivative test. So from negative infinity to negative 1, f prime is positive, f double prime is still positive, the tangent lines are still, the tangent lines still have positive slopes. Okay, so you have that from negative 2 to negative 1, f is increasing, and it concaves upwards. At x equals negative 1 exactly, it's a possible point of inflection. It's undefined. Negative 1, f prime is positive. We still don't know what's the behavior of f at x equals negative 1. So let's fill out the next row. So from negative 1 to 0, negative 1 to 0, f prime is positive. However, the tangent lines have negative slopes this time around. Okay, so f double prime is negative. Therefore, at x equals negative 1, f double prime changes sign, so it's a point of inflection. And in this interval, f is increasing and it concaves downwards. So at x equals 0, f prime is 0, f double prime is also 0. The tangent line is horizontal. So we still don't know what the behavior of f at exactly x equal to 0. So let's fill out the next row. From 0 to 1, 0 to 1, f prime is negative. However, f double prime is negative. You have negative slopes. Therefore, this is a relative maximum by the first derivative test. And in this interval, f is decreasing, but it's still concave down. At x equals 1, we have a possible point of inflection. So let's fill out the next row. 1, 2, 3 minus square root of 2. So this is still negative, f prime. F double prime is positive. So this is a point of inflection, decreasing, concave down. At 3 minus square root of 2, it's 0. has positive, so the tangent lines have positive slope. So by the second derivative test, you have a relative minimum, and from 3 minus square root of 2 to positive infinity, f prime is positive and f double prime is also positive. So it's increasing and it concaves upwards. So let us now proceed with the possible graph of f. So this is your origin. So negative 1, negative 2, 1, 2. So 3 minus square root of 2 should be somewhere between 1 and 2. Now, you can pretty much draw your curve anywhere as long as it satisfies uh, the the behavior of f prime and f double prime. So we know that f should be decreasing and concave up from negative infinity to negative 2. So it should look something like this. It's decreasing but concave up. Of course, you can translate your curve around. This is just a possible graph. So anyway, you can translate it around here or here. Doesn't really matter. So anyway, from negative, so we have a relative minimum at x equals negative 2. Then from negative infinity to negative 1, it's increasing, but it's still concave upward to this. Okay, so at x equals negative 1, okay, let me redraw that. Okay, so as long as we satisfy the general behavior of f, that's fine. Okay, at x equals negative 1, you have a point of inflection, and from negative 1 to 0, it's increasing and it concaves downwards. So you have a point of inflection around here. And then it's still increasing, but it concaves downwards. Okay, you have a relative maximum at x equals 0. Then it decreases and it concaves downwards. Okay. At x equals 1, you have a point of inflection, and then it decreases and concaves downwards. So at 3 minus square root of 2, you have a relative minimum. Then it increases and it concaves upwards. Okay, I think that should be it.